Hello and welcome. Today we take the next step in AI agent engineering, moving from loop engineering to graph engineering. We'll see how the two approaches differ, how to migrate in practice, and what you gain from the move. Our starting point is the four familiar loops. The agent loop, model and tools until the task is done. The verification loop, after every change, define a check that would fail if you're wrong, and actually run it. The event-driven loop. When you're waiting on something external, arm a trigger instead of blocking. And the hill-climbing loop. Generate a candidate, score it, keep the best, and repeat. But loops have a ceiling. Everything runs serially, even steps that don't depend on each other at all. The order is a writing habit, not a declaration of real dependency. When you crash midway, you start everything over. Verification depends on the operator's discipline, and under pressure, discipline erodes. And a single context simply cannot hold a truly large task. The idea of graph engineering is simple. Describe the work as a graph, nodes of work and edges of dependency. Whatever is not connected by an edge runs in parallel. And notice, the loops don't disappear. They become structures inside the graph. 6 building blocks. A node, a focused agent with an input-output contract. An edge, a declaration of real dependency. Fan-out, independent items running as parallel nodes. Pipeline, the default. Each item flows at its own pace, with no needless waiting. A barrier, a deliberate sync point, only when you need all the results together. And a cycle, a loop kept on purpose, because there is real feedback between rounds. And here is the mapping. The agent loop becomes a node. The verification loop becomes verification nodes sitting on the edges, including an adversarial panel, several independent checkers, and a majority vote. The event-driven loop becomes an event edge, waking the branch when something happens outside. And the hill-climbing loop becomes a cycle with a judge panel, a whole generation of candidates every round. The recurring principle, what used to be discipline, becomes structure. The migration itself, 7 steps. 1. Break the loop body into nodes with clear contracts. 2. Draw only edges of real dependency. 3. Turn per item iteration into fan-out. 4. Default to pipeline. Add a barrier only with justification. 5. Keep cycles only where there is real feedback. 6. Make verification structural, with adversarial panels for critical claims. And 7. Keep a journal of every node's output, so you can resume exactly where you stopped. And what do you gain? Wall clock time. Branches run in parallel, and the run takes as long as the slowest branch, not the sum of all of them. Structural reliability. No artifact moves on without verification. Resumability. Fix one node and rerun only what is downstream of it. Scale beyond a single context. Full observability of progress. And budget as a lever. The same graph, wide or narrow, as needed. Finally, the graph is not a religion. A deep dependency chain? Stay with a loop. Tight shared state? Isolate or stay serial. A small task? Just do it. The rule of thumb, ask what truly depends on what. If the answer draws a wide tree, it's a graph. If it draws a straight line, it's a loop. And either way, no artifact is done without a green check. Thanks for watching, and good luck with the migration.